In this third video, we'll use Graham's law to calculate the root mean squared. So here's the formula. Okay. So let's say the gas we have is oxygen gas at 50 degrees Celsius. So the molecular mass is 32 grams. The temperature must be in Kelvin, so we take 50 degrees Celsius plus 273 is equal to 323 Kelvin, and the R value has to be the 8.31 liters kPa per mole Kelvin. Okay, so we plug that in and plug in our numbers. Grams per mole. All right, and a liter kPa is the same thing as a joule, so we could substitute that in if we wanted to, and then we calculate it, and we get the answer of 15.8 meters per second. Okay. So that's, again, it's easier to think of that as a speed, and that's how fast it'll take your gas to diffuse or effuse. Now, another form of Graham's law that is used more often is the following form. If the root mean squared of gas 1 is 3RT over the molecular mass of gas 1, and we could use the same equation for a second gas, what we could do is we could set up a ratio between these two, a fraction. So the root mean square of gas 1 over the root mean square of gas 2 would be equal to the square root of 3RT molecular mass gas 1 over 3RT over molecular mass gas 2. Well, when you divide by the fraction, it's the same thing as by multiplying by the inverse. So, same thing as multiplying by the inverse. So therefore, this would cancel and this would cancel, and this simplifies to the root mean square of gas 1 over the root mean square of gas 2 is equal to the square root of the molecular mass of gas 2 over the molecular mass of gas 1. This is the more commonly used form of Graham's law. So let's use that equation and do an example. Let's say oxygen gas diffuses at 15.1 meters per second at 25 degrees Celsius. What is the diffusion rate of neon gas at the same temperature? Okay, so it doesn't matter who you call gas 1 and who you call gas 2. Okay? Now, since we're solving for the diffusion rate, it would probably be easier if we called gas 1 neon, because then it'll automatically be in the numerator, and we call the oxygen gas 2, and therefore the molecular mass of gas 2 up here over the molecular mass of gas 1. Okay, so we know that the diffusion rate of the oxygen, or gas 2, would be, in this problem, 15.1 meters per second. The molecular mass of oxygen is 32 grams per mole. The molecular mass of neon is 20 grams per mole. So then we do our arithmetic. 32 divided by 20. Take the square root of that. Multiply it by 15.1, and I get the root mean squared. The root mean squared of neon to be 19.1 meters per second. Okay? So that's how you're going to use the Graham's law for the problems in the homework.